Point your finger at a distant object, like a clock on the wall or a tree outside your window. Now, close your left eye, then open it and close your right. Did the object seem to jump? For most of us, in one of those views, our finger remains perfectly aligned with the target. That eye, the one that holds the world steady, is your dominant eye. It's a feature of our biology that over 2/3 of humanity shares, yet almost never thinks about, a silent, invisible preference that shapes how we see and interact with everything around us. But what is a dominant eye, really? It's a common misconception that it's the eye with better vision. While that can sometimes be the case, ocular dominance has nothing to do with how clearly you see. A person with 20/20 vision in both eyes will still have one that their brain prefers. Essentially, ocular dominance is about neural preference. It's the eye that your brain trusts more for positional information, for telling you precisely where something is in space. To understand this, let's try a simple experiment. You can do this right now. Extend your arms and create a small triangular window with your hands. With both eyes open, look through that window and center a small, distant object inside it. Now, slowly bring your hands toward your face, keeping the object centered in the frame. Your hands will naturally drift towards one of your eyes. That is your dominant eye. It's the one your brain has designated as its primary anchor to the visual world. For about 65% of the population, this will be the right eye. For about 30%, it's the left. A very small percentage of people have no strong preference, a state known as mixed ocular dominance. Interestingly, this doesn't always align with handedness. While most right-handed people are right-eye dominant, a significant portion, perhaps up to a quarter, are cross-dominant, meaning they are right-handed but left-eyed, or vice versa. This hints that the mechanism behind this preference is more complex than a simple wiring diagram. So, why does the brain need to pick a favorite? To understand this, we need to journey into the very architecture of our perception. Our two eyes are one of the great triumphs of evolution. Set a few inches apart on our heads, they each capture a slightly different image of the world. This difference is called binocular disparity. Hold a finger close to your nose and alternate closing each eye. The finger appears to leap from side to side against the background. Each eye is reporting a different reality. The brain is then faced with a monumental task: to take these two flat, slightly mismatched images and fuse them into a single, seamless, three-dimensional experience. This magical act of neural processing is called stereopsis, and it's what gives us our rich sense of depth perception. It allows us to judge distances, to navigate a crowded room without collision, and to appreciate the vastness of a landscape. But what if there's a conflict? What happens when the brain needs to perform a task that requires not just a general sense of depth, but absolute positional accuracy? Imagine you are an archer, trying to hit a distant target. Your brain is receiving two slightly different signals about where that target is. Averaging them might land your arrow somewhere in the middle, but not precisely where you aim. This is where ocular dominance becomes critical. It turns out, the brain doesn't treat the input from both eyes equally for all tasks. It establishes a hierarchy. Essentially, your dominant eye acts as the primary sighting tool. Its view of the world is given priority when it comes to alignment and positioning. The brain uses the information from this eye to lock onto a target, to create a stable reference point. The non-dominant eye isn't turned off, far from it. Its input is still crucial. It provides peripheral context, enhances the field of view, and contributes vital information for that all-important depth perception. But for the specific task of aiming, it takes a supporting role. One eye says, "This is exactly where it is," and the other adds, "and this is everything around it." It's a beautiful, efficient division of labor, a system designed by evolution to resolve ambiguity and allow for decisive action. In short, your dominant eye is the lead surveyor, while your non-dominant eye is the landscape artist, and together they create your unified perception of reality. So, what does this all mean from a grander perspective? Why would our species, and many others, develop this trait? The answer, as it so often does, likely lies deep in our evolutionary past. Imagine our ancestors on the plains of Africa, billions of years ago. Survival depended on skills that required immense visual precision. Throwing a spear at a moving animal, chipping a flint tool into a sharp edge, or even identifying a distant predator required the brain to make fast, accurate judgments about space and distance. In this high-stakes environment, having a dominant eye would have been a significant advantage. It simplifies the complex neural calculation needed for aiming. Instead of trying to reconcile two competing signals in a split second, the brain could rely on a single, trusted source. This would reduce visual noise and hesitation, making the hunter more effective and the toolmaker more precise. A clear line of sight, guided by a dominant eye, could have been the difference between a meal and starvation, between survival and extinction. This isn't just a story about humanity. Evidence suggests that this kind of specialization is a common evolutionary strategy. Birds of prey, like eagles, which must calculate terrifyingly fast dives to catch their quarry, show clear ocular dominance. Our fellow mammals, from cats to dogs, also have a preferred eye, often tested by seeing which eye they use to peer into a small hole. It's a solution that nature has stumbled upon again and again. The problem of how to aim accurately in a three-dimensional world is solved, in many species, by appointing a single eye as the director of the scene. This also brings us back to the curious link with handedness. The brain is lateralized, meaning its two hemispheres are specialized for different functions. The left hemisphere, for example, typically controls the right side of the body and is heavily involved in language. The right hemisphere controls the left side of the body and is more involved in spatial processing. The fact that most humans are right-handed and right-eye dominant suggests a deep connection in how our brains decided to delegate tasks. This pattern of specialization, from our hands to our eyes, points to an overarching organizational principle in our nervous system, honed over millions of years of evolution to make us more efficient operators in the physical world. This raises a classic question of biology. Is this preference we all have determined by our genes, or is it something we learn? Is it nature or nurture? The current evidence suggests that, like many aspects of our being, it's a rich and complex dialogue between the two. There appears to be a strong genetic component. Studies on infants show that a preference for one eye can be detected very early in life, long before a child could consciously practice and develop one. Ocular dominance seems to be part of our initial biological blueprint. But what if something disrupts that plan? Here, the incredible plasticity of the brain comes into play. Our brains are not static, hardwired machines. They are constantly adapting to our experiences. For instance, if a person suffers a serious injury or illness that permanently damages the vision in their dominant eye, the brain doesn't just give up. Over time, it will slowly and methodically shift its preference, promoting the non-dominant eye to the primary role. It rewires its own circuits to make the best of the available information. We see this process even more clearly in the treatment of conditions like amblyopia, or lazy eye, where the neural connection to one eye is weak. A common treatment is to place a patch over the stronger, dominant eye. This forces the brain to rely solely on the weaker eye, strengthening its neural pathways and, in effect, forcing a shift in dominance. In short, while our genes may hand us a default setting for ocular dominance, our life experiences hold the power to edit that setting. It's a testament to the brain's remarkable ability to adapt and reorganize itself in the face of new challenges. Ultimately, does this subtle, unconscious preference really matter in our modern lives? For most of us, most of the time, it operates completely in the background. But in certain fields, an awareness of your dominant eye is not just helpful, it's essential. Consider the world of sports. In archery, shooting, and billiards, aligning your dominant eye with the sight or the line of the shot is fundamental to accuracy. A baseball batter who is cross-dominant might need to adjust their head position to get a better view of the incoming pitch. Golfers often use their dominant eye to line up a putt. For these athletes, understanding their own visual wiring is a key part of mastering their craft. This extends beyond sports into a range of professions. A photographer instinctively brings the camera's viewfinder to their dominant eye. A microscope operator, like a biologist or a surgeon, does the same to ensure a stable and clear view. A pilot scanning instruments and the horizon is constantly relying on this built-in hierarchy of vision to process information quickly and accurately. Our dominant eye is a silent partner in any task that demands precision, a hidden feature that helps guide our most focused and deliberate actions. So, what does this all mean? This small quirk of our vision, this preference for one eye over the other, is far more than a simple curiosity. It's a window into the intricate engineering of our consciousness. It reveals the brain's elegant, economical solution to the profound challenge of perceiving a three-dimensional world. Ocular dominance is not a weakness or an imbalance. It is a sophisticated feature, a system for prioritizing information and resolving ambiguity, likely forged in the crucible of evolution to give our ancestors an edge. It's a quiet reminder that our perception of reality isn't a passive recording of the outside world, but an active, dynamic construction happening inside our minds. There is an unseen director, a preference coded deep within our neural architecture, choreographing the flow of visual data before it ever reaches our awareness. Ultimately, the story of the dominant eye is the story of the brain's constant, tireless effort to create a single, stable reality from a sea of conflicting information. It's a fundamental part of our biological heritage, an ancient system that, to this day, shapes how every single one of us sees the universe. If you enjoy seeing the world through a different lens, consider subscribing for more.